I'm getting closer.
Look at that guy. He's got no wheels. What a bender. Can't even... Oh, my. Well, yup. That's me. You're probably wondering how I got here. I'm the best.
Yo, Brian, what are we doing out here?
I'm gonna confess my love. Will you take my hand?
Why would I ever accept someone who's so bad at physics?
Brian Pooh, a failing AP Physics student. He was once a gunslinging cowboy from the West. But now, he can barely score on a test. Just can't grasp the concepts. So now he lives a life of complete sadness. Brian Pooh needs help. And we're gonna help him, because he's a bro.
So AP Physics is different from all the other AP classes because it's really on you as a student to figure out what you do and do not know and get help for those things that you do not know. Because all these concepts build upon each other, if you fall behind once and if you don't resolve the issue, you're gonna keep on staying behind rather than like fixing your issue at hand. So you always need to make sure that you yourself are taking care of what you need to know and what you need help on.
Hey, yo, Brian, what are you doing? What are you doing? Stop! What is that?
Look like I want to die.
Brian, you can't even fit the spoon into the socket of an outlet. That's plastic. That doesn't even work.
Unlimited energy.
No, Brian, that's not how it works. Why do you want to die? You can't die yet.
I don't want to live on this planet.
Brian, you're going to need to learn something, and you're going to save the world.
Circular motion. What is uniform circular motion? An object goes around in a circle. The speed v equals omega r.
Hey, yo, Brian, wake up. Brian, wake up. You can't just fall asleep during lectures like that.
6.3 meters per second.
Dude, no, that's not what a good AP Physics student would do. You gotta wake up. You gotta pay attention, dude. That's important stuff. That's some good concepts right there.
Just numbers.
It's not just numbers. There's an omega sign there.
Omega squared.
Be an active listener and learner in this class. When Miss Chioni plays physics videos during class, don't fall asleep or zone out. Instead, actively take notes throughout the video so you can stay engaged, as well as reference them later when you're having trouble with the key concepts. An example of how you should take notes when Miss Chioni shows you a video in class. So when the person is talking, identify which parts of what they're saying are critical to the concept being explained and which are just extra details. Write key definitions and concepts outlined in the video and what they mean in your own words so you have an idea of what's being explained. In addition, write all the important equations that go along with the concepts so you understand the mathematical explanation behind the physical concepts. Include important diagrams that help your understanding and how they connect to what is being explained so you have a visual representation of all the equations and definitions you already have in your notes. This way you'll stay engaged throughout the video and you have something to come back to when you study for your tests. That's a concise way to summarize whatever you learned in the chapter. Brian, now that you're done with your physics notes, you should write down a study group question for tomorrow's study group.
Oh yeah, I totally forgot.
Brian, what kind of questions? Someone hit him with a stick.
I don't
hit
know.
him. Ow! When coming up with study group questions, it's important to have your question be actually relevant. I mean that your question shouldn't just be extremely vague, it should be insightful and deep. One way to do this is to look at the checkpoint questions or look at the topics that you're having difficulty with understanding, because study group questions allow you to discuss these concepts, which are crucial throughout the progression of the chapter. Furthermore, you want these questions to consider previous chapters, because each chapter builds off upon the next, and these concepts carry over from chapter to chapter. Furthermore, you're going to want these questions to also have, you want them to have meaning on the understanding of the concepts rather than the execution of the concepts. You want to be able to identify what's going on and what's happening.
So in this problem, we're actually really solving for the gravitational potential energy. So what's the first step that you guys would do?
I think we should just solve for it. I mean, what's wrong with that?
Are you actually focusing on the problem, Brian?
Yeah, I'm doing it right here. Oh, ooh,
What are you doing, Brian?
I can't explain. I can explain.
I got this. When working in problem-solving groups, it's important that you're present. You have to actually be active within the group and cooperate and contribute in order to get the most out of it. It's a good way to increase your ability when you're solving problems, and it also allows you to learn other methods from what other people do. You get to see their work process, you get to see the way that they see the problems. It's just multiple methods that would improve your own mindset when it comes to solving these problems. If you don't actually participate and you get distracted or you let someone do it for you, then you're defeating the whole purpose and causing yourself to fall behind, in the sense that you aren't opening up your mind, you're keeping it closed so that you aren't improving and you aren't able to solve these problems in a more efficient manner.
It's some nice weather for physics today, but I need help on this one problem. Which equation do you use here?
A squared plus B squared equals C squared.
Is that really right?
Flex time is extremely valuable. Don't use flex just to talk to your friends or decide where you're going to go for lunch. Use flex as a tool to help you with problems that you find challenging. Use it to get help from Ms. Trioni and check your homework solutions with the solution binder. This way you'll be better equipped to do well on tests and get better time management skills.
Hey Brian, what are you doing over here?
I'm doing physics homework right now.
Shouldn't you have done this last night?
I was watching Power Rangers.
How are you gonna learn any of the things we've done on the homework?
I'm just gonna I'm gonna memorize the answer, just copy them down and put it clearly.
Bad physics student.
Charlie 6 attack force.
When working on your homework problems, it's a good idea to do them ahead of time. Don't do it the night before or the day of. This will allow you time to understand the problem rather than rush it and crunch numbers. When you actually understand the problem, it helps when developing those problem-solving skills. This is something that you're going to need through all the concepts, and it'll eventually get better as long as you keep doing this. Furthermore, if you took time on some problems and you found it difficult and you just really wanted to skip it, those are the problems that you should probably focus on. The best way to overcome those difficult problems is to just keep practicing them. You begin to understand the way that you should be looking at the problem, and you start getting the hang of the method and the procedure that you should actually start to take. That's one way to develop your problem-solving skills.
You won't be successful in this class by just doing the bare minimum homework problems. In order to gain the skills necessary to succeed, you need to do extra problems. You need to do the problems at the end of the chapter, the sample problems in the book, so you'll be better equipped to handle any kind of trick problem that Ms. Trioni gives you on the test.
So when working with physics problems, as you can see, there's many different equations we need to remember and know how to manipulate. If we're looking at this problem right here, the first step we need to do is figure out what the problem's actually asking for. In this case, it's asking for velocity final. And by applying our knowledge, we know we only really need to apply one equation, and that is the conservation of energy. So that says initial energy is equal to final energy. From here, we need to manipulate our equations in order to isolate for the variable that we really want, which is velocity final. So we can define an energy as kinetic plus potential gravitational energy, and from there we can define both kinetic and gravitational potential energy in terms of variables that we do know, such as mass and velocity. Now we need to substitute those terms back into our initial equation, which was the energy initial. So substituting, we have this long equation which has many variables, but remember, all we're really looking for is velocity final, and we know all the other terms. So this is basically a simple algebra problem. which we find a velocity final to be the square root of some of these terms. Once we plug in all the numbers or all the knowns into our equations, we are left with what we want to find initially, which is velocity final. So while there are many different equations that are used throughout all of physics, most of the problems just really come down to which two equations you need to manipulate in order to find one variable. So many difficult problems turn out to be very simple.
One of the primary ways to cement your understanding of problem solving is through the 5-step problem solving technique. It forces you to visualize the problem, list out the potential equations and your givens. This will allow you to have a better understanding with the math when you're actually performing these problems. The hardest thing about problem solving isn't finding that number answer, it's actually identifying from the problem the information that you're given and which equations to use in order to get that final answer. Manipulating the equations is difficult, and it's even more difficult when your variables aren't complete. So it forces you to really think about your equations and think about how you're going to actually approach the problem.
3, 2, 1. Brian, have you been paying attention to what we're supposed to be doing in this lab?
Yeah, Leo dropped first. What? Yeah,
How does that work?
He's bigger. Bigger things always drop first.
Yo, dude, you know, when you told me to conduct this experiment, there wasn't a pad here, so when I dropped the ball, I could have damaged the floor.
Oh yeah, then we forgot the data table.
Yeah, that, you know, Brian, during the lab, you're supposed to look at the, you're supposed to look at the concepts, Brian.
What are you doing, Brian?
Dude, you can't mistreat the lab equipment like that.
I own that.
No, you don't.
Oh, I don't own that.
Yeah, you don't own that. You can't mistreat lab equipment like that, Brian. Pick it up.
So for work habits during labs or activities, you want to be very diligent when you're doing your work because you want to collect your data very efficiently, but also be able to collect good data, because when you're analyzing it at home, you don't want to realize that the data you got during the lab was all messed up and you would have to come back in during flex or office hours. And also pay attention to what's exactly happening during the lab. Let's say a pulley is coming down and you're paying attention to why it's accelerating over time. Pay attention to whether or not the mass hits anything else during the lab. So just be careful when you're working with the labs so that you're going to get good data. So when taking care of lab equipment, you want to be careful when you're handling the equipment because you don't want to get bad data because you damage the devices. And that means you're going to be a bad grade and you'd have to pay for the devices. They're pretty expensive. So in order to take care of them, just make sure you handle them very carefully. Use both your hands and always have a cushion whenever something's falling so you don't have it hit the ground. So when you're using the lab equipment out of the lab drawers, you always want to keep it organized because you want to save time when you're working with your lab. You want as much time during the lab to get your data because you don't want to come in during flex or office hours to make up some lab data that you needed before. And another thing just to watch out for is you don't want to be paying for the equipment that you lost or may not have lost, so keep track of what's inside your lab drawer.
Brian, what are you doing?
I'm putting the finishing touches on my lab.
Dude, I was looking for you during lunch. Why aren't you at 5th block right now?
Dude,
Finishing touches?
5th block is just intro to engineering.
No, dude. You said finishing touches, bro. That's like 1 page. A lab report? Dude, that's not gonna cut it.
But I got it done.
Still, that's not gonna cut it for
That's-
AP Physics, dude. What are you?
Dude,
Come on. You gotta actually put in the effort.
She's gonna give me is an NA.
Oh my god, Brian, no, that's not the point. That's not the point. You know what? Stick.
But it's what you know. It's what you.
So when writing lab or activity reports, you want to be very thorough in your analysis of what happens during the lab and of what you see from the data. But you also want to apply what knowledge you learned during your chapters of reading and what's presented in class, and let's say like gravity or forces, so that you can understand what is happening and explain how they can be applied onto your activity or lab.
When analyzing the data that you've collected from your lab, you want to make sure that the data you've collected is reasonable and consistent. So in this run, we have a graph that looks like this. Similarly, in the second trial, the graph looks similar, and the same thing in the third. So we have this trend, so we have this idea of what good data looks like. However, in this different trial, or in the same experiment but different result, you have a graph that doesn't look like the last few, and this is how you know this is bad data. And this is something you'd have to talk about in your lab report. But yeah, you don't want to neglect data like this, or you don't want to discuss why it's different.
How did you finish this so fast?
Guess I'm just the best.
What'd you do wrong here?
You mean, what did I do right?
Stick!
In the new format of the test, where none of the questions are multiple choice, it's really easy to make a simple math mistake and get the whole question wrong. In order to avoid getting like an F or an NA on the test, you need to do at least 4 questions and check each of them very, very carefully so you know you got them right for sure. Then with the time remaining, attempt the rest of the questions on the test so you know for sure you at least got a C.
Following the new format of the test, the problems are all or nothing. So like if you won't get partial credit for having just the work, you actually need the right answer. So you need to make sure that when you're doing the problems that the answer is correct. You want to double check it. That's why you don't want to focus on finishing the test. You want to finish the problems that you know that you can do. Therefore, not only are you able to evaluate yourself, but you're also able to evaluate the quality of your work.
Velocity equals distance over time. V equals mc squared.
Look at physics, bro.
Support yourself and other students in the class by making a group chat with 3 to 4 students at the beginning of the year, so you have the tools to call people and ask them for help when you need it outside of school hours, and you can collaborate on challenging homework problems and practice problems throughout the year.
Also, when you support other students by teaching them the way that you've done a certain problem, let's say, you're not only helping them, you're helping yourself, because it forces you to clarify the steps that you've taken in a way not only that they understand, but you understand. So in a sense, it makes your own work clear to you so that you understand even better. So it's a win-win situation when you help other students.
Yo, Brian, boo! I know you! Squarehead!
You don't even know me. You're just a potato head.
You are! Barely even looks it.
Yo, is everyone buckled?
Yes.
That's right,
Where am I?
Oh, you don't need to worry about that, Brian. It's okay. It's okay. It's been a while.
Donnie?
Donnie, get out of here. Go.
He's in my physics class.
Shut up. You don't have to worry about physics anymore. You know, you've gone through so many endearments, so many trials that I've put you through, but the stick method clearly doesn't work. So we're gonna have to wash it away.
No. I'll be better, I swear.
You'll be. Oh yeah, I know you'll be better. I know you'll be better.
Why did you waterboard me? What was that?
Right. In AP Physics, when your methods don't work, you can't just stick to it. Sometimes you gotta wash it away and find another method. It's okay. You'll be better physics now. I'll see you later, bro.
Boy, get me out of these chains! Okay.